Hello everybody and welcome back. Root Beer here with more of the 2002 Pascal competition. That's the grade 9 multiple choice competition. We're going to be starting question 21. Question 21 is special. It's the first one in part C. These are the last 5 questions on the contest. They're the hardest questions that there are for this particular Pascal paper. And so I really do encourage you to click the link in the description, download a copy of the contest, try these questions for yourself before you watch my video for 21 or the next one for 22, 23, 24, 25. These are the really important, really challenging questions, and you really should give them a shot before you watch these videos. Okay? That said, let's take a look at question number 21 on the 2002 Pascal. A rectangular block with dimensions 4 centimeters, 5 centimeters, and 6 centimeters, is made up of cubes with each side length 1 centimeter. If these 1 centimeter cubed cubes are removed from this larger rectangular block, what is the minimum number of these cubes that must be removed so that the resulting solid itself is a cube? Okay, that's a lot of the word cube there. But I think I understand. So let's draw a little bit of a picture as to what's going on. So we don't have a cube. We don't start off with a cube. We start off with a rectangular prism. And one side is 4 centimeters. And we get another side that is 6 centimeters. I'm just botching this picture up. I'm going to redraw it again a little bigger. I don't like having ugly pictures. Rushed pictures, sure. I'm not a big fan of using my ruler all the time, but I don't really like ugly pictures sitting around. Alright, so this will be my shorter side length, so that's going to have side length of 4 here. Here we'll have 5, so that's 1, 2, 3, 4, and 5. Well, it's turning out a little better. Now if I want 6 on this side, alright, not bad at all. So we've got 4 centimeters, 5 centimeters, and 6 centimeters. So our cube is made up of all these tinier cubes. And what we're doing is we're trying to remove them to get the next largest cube. Or to remove enough of these so that we can form a cube. Okay. So we want to know what exactly. How many cubes must be removed so the resulting solid itself is a cube? So we're just removing smaller cubes. We're not taking them away and then reforming the whole structure. So how many cubes are we playing with here? So 4 by 5 by 6. So that should tell me the volume in terms of 1 centimeter cubed cubes. And that's 20 times 6. So that should be 120 1 centimeter cubed cubes. Okay. So if I were removing them and trying to get the next largest cube, well, I need to start thinking of some cubes. I could leave myself with just 1 cube, because that's 1 times 1 times 1. I could leave myself with maybe a 2 by 3. Maybe I can take away enough that I leave a little 2 by 3. That would leave me with 8 cubes. Or 3 to the 3, I could have a 3 by 3 by 3 cube lurking in here somewhere. That'd take 27 cubes. Or I could have one made out of 64. That'd be 4 by 4 by 4 cube. How about 5? We'll go up to 6 because, there's no way we can get a 7 by 7 by 7. We don't have the proper dimensions for that. There's no way we can add dimensions here. And when you think about it, we can't even do the 5 or the 6 one. At best, we could do trim the other sides down until we have a 4 by 4 by 4. But let's just take a look here. So if we were to somehow pare everything down to a 6 by 6 by 6 cube, we'd have 216 cubes. But we start with 120 and we're only allowed to remove. So these two, there's just too many cubes. There's no way we can remove and yet somehow add on 96 cubes. There's no way that's happening. So we could have a 1 by 1 by 1 cube. If we took away all the other cubes. Or we could have a 2 by 2 by 2 cube. That's certainly possible. Let's just take a look here. Or you know what? I'm spying a 3 by 3 by 3. So it's definitely possible to remove and get 3 by 3. It's just going to sit right here in the corner. And actually, we can get a 4 by 4 by 4 cube. So we'd have to remove one whole side and then these 2 extra layers over here. But we could definitely get a 4 by 4 by 4 cube. So that's the best we could have hoped for. We can't get a 5 by 5 by 5. There's too many cubes required for that. We don't start with enough cubes to remove and then somehow gain 5 cubes somewhere down the line. So it looks like we can remove the blocks. How many will we need? Well, we start with 120. We want to end up with 64. And we visually can do it without rearranging. So we just need to ask ourselves how many cubes are removed. Well, what's the difference between 120 cubes that we start with and 64 that we end up with? That's 6. And it's 56 cubes. So 56 cubes removed. 56, 56, 56. There it is, hiding on the end. So our answer to 21 is E. So that was the first of the Part C questions. I really do hope you downloaded a copy of the contest and tried it for yourself. We're going to move on to question number 22 now, but we'll take a look at that in the next video.